Chain abstraction or chain fusion is all about making blockchains work together. It is about transferring funds from one chain to another. It's about creating transactions or letting one chain create transactions on another chain. This video, I will do a walkthrough. I will show you how you can use the cryptographic capabilities of your standard Ethereum wallet, MetaMask, to create an identity that then can be used to interact with an application on the ICP blockchain. And why is this interesting? I mean, from the perspective of an Ethereum user, that means that you can log into an ICP application without knowing anything about how ICP identities work. You don't need to download an ICP wallet or anything. You can just use the standard way of logging in that you're used to. And from the perspective of a project, that means that onboarding Ethereum user just became so much easier because they don't have to care about the details of how ICP identities work. You'll find a link to the repository with the code in the show notes. And this is a really bare bones example. So I will be focusing only on the logging in the user to ICP. You can use this repository as a starting point, as a template for your project. But before we dig in, let's have a look at the sort of the bird's eye view of the setup. So the very basic setup of this application looks like this. You have a front end. This is a React-based front end that wants to make an authenticated call to this Rust-based backend canister. And for this video, I won't be going into details about how an application on the internet computer works, what canisters are, etc. So I'm presuming you have some basic knowledge about that before moving forward. To enable the sign-in with the Ethereum flow, we will add another component to the mix, and that is a pre-built sign-in with Ethereum provider canister. So sign-in with Ethereum is a standard. It's a standard that defines a message format. It defines the message and how it will be displayed to the end user when you sign this message. So basically, it gives the user a much better user experience. It clearly states like to which website you're logging in, etc. It also provides some security features preventing you from logging into the wrong website. You know, it prevents phishing attacks to some extent. And the login flow starts with the application front end making a call to the sign in with Ethereum provider canister and asks it to prepare the login. And what happens there is that the sign in with Ethereum provider canister prepares this message that the user is going to sign based on some settings that I will show you later, and then returns it to the front end. The front end then asks the user to sign this message using MetaMask and takes the signature and returns that to the sign-in with Ethereum provider canister. And once the provider canister has received that signature, it can verify the signature against the message and thereby securely establishing the knowledge that which user signed the message, right? And once it knows which user signed the message, it can generate what is called a delegate identity and return that to the application front end. And once the application front end has that identity, basically now we're done. Now the application front end can make authenticated calls to the application backend. So let's dig in and have a look at the code. So we will start out by cloning a template that I released just the other day. It's a basic ICP application starter template, including a Rust-based backend and a React-based frontend. It's a kind of a little bit opinionated. It's a batteries included template, so it includes stuff like Tailwind for styling. It's built upon Vite for great developer experience, etc. Let's see. So cloning that template and calling it the sign in with Ethereum demo. And okay, next up we will start the local replica of ICP in the background. And installing all the dependencies for the project. After that, we can actually try to deploy the project, and it should run directly. Okay, cool. It works. And this is how it looks when you deploy this starter template. It's the backend canister is a canister that exposes just one endpoint, and that is the greet function. And when you provide it with a name, and it returns a greeting. Basically, it's a basic like hello world example. So I'll add a name here. I push the greet button, and it returns a greeting. So back to the code. And next up, we will add the provider canister to our dfx.json. So like I mentioned, this is a pre-built canister that we can just drop into our project, which is very convenient. Let's just quickly switch over to the web browser. Let's see. Yeah. I just wanted to show you the sign in with Ethereum repository. So everything is available on GitHub. And by everything, I mean the sign in with Ethereum project consists of a number of components, which we will be using in this demo. So you have the sign in with Ethereum library, which is a Rust-based library. And next up, you have the sign in with Ethereum provider, which is the provider canister we will be using. So instead of actually implementing the library into our canister, which we could have done, we will take the short path, which is using this pre-built provider canister. And then you have additional demos. And we also have the sign-in with the Ethereum identity React hook that we will later use in the front end to use the identity. So now back to the code. We have added the sign-in with Ethereum provider canister to our dfx.json, specifying the URLs for both the candid, which is the interface definition of the canister, and the precompiled WebAssembly code. When deploying the sign-in with Ethereum canister, we need to provide it with some settings that will determine its behavior. So let's move those, or not. Let's create a deploy script to make our lives easier. And this deploy script we will use for deploying all the canisters in this project. So from the top here, let's take a look. We are creating the backend canister, we're creating the frontend canister, as well as the sign-in with Ethereum provider canister. And then we deploy the sign-in with provider canister with some settings. We specify that the domain is localhost, and we need to configure it with a salt to increase security. We can specify both the sign-in expires message, which determines for how long time is the actual sign-in message valid, and we can also define the duration of the session, which is how long time this identity is valid for authenticating. And finally, we give it some targets, and these targets are canister principles. So if we were to omit these targets, then the identity generated by the provided canister would be valid for interacting with any canister. But here we can narrow things down, and we can instruct the provided canister to say, like, the identity that you generate will only be valid when communicating or interacting with number one, the provider canister itself, and also the backend canister of our project. So this is an extra layer of security, and I really recommend you to set this quite strictly to only allow the identity to be used for the canisters included in your project. Finally, we deploy the backend and the front end and generate the interface specification. So let's see, bash deploy and see how that goes. Great, all canisters deployed, the backend, the front end, and the provider canister. And now with the backend configured, let's move over to the front end side of things. And what we are lacking is a library in our React front end to interact with the Ethereum wallet with MetaMask. And I will be using RainbowKit. So RainbowKit together with WAGMI and VM is a combination that setup allows you to really simply get this connect button, select the chain, etc. So let's install RainbowKit together with the required dependencies, including TanStack React Query, which is one of the greatest React libraries out there. Taking care of all the query handling, or the requests and the caching, etc. Now with the Ethereum wallet libraries in place, we also need to add the sign in with Ethereum component, this component that is specific for this internet computer implementation of sign in with Ethereum. So let's head back to the sign in with Ethereum GitHub repository and find that. Yeah, and once that have been set up, we can attempt to run the project in dev mode, and let's see how things look. There's no difference, of course, because we haven't made any changes to the front end code. So let's start tying all this together. Let's head over to the main TSX file. Sorry, the app TSX file. And to start with, let's remove some of the template stuff. And I think we can remove that greeting form as well, right? Okay, so now basically we have a blank screen that we can add the connect button to. RainbowKit and WAGMI needs to be configured with some settings. So let's just copy that, the default stuff from their web page, and add it to our project. Starting with the default config, where you tell WAGMI and RainbowKit which chains we will be using for this project. And we so let's import that, and let's do only mainnet for this project. Okay. Once we have created this config, we can connect it to the WAGMI provider that we will need to wrap our application with to make the wallet accessible in everywhere throughout our application. We also need to wrap our application in the RainbowKit provider, and the RainbowKit provider provides the user interface where we select the wallet and chain, etc. Once we have the provider set up, we can move on to actually add a connect button to our main application file, and hopefully we will see have the ability to choose which chain we connect to. Oh, I forgot something. We need to add some styles. So Rainbow Kit comes with with some styles that make the button actually look like a button and not like just black text. So let's add that and move back. Yeah. So now we have the ability to select network. We'll select mainnet and boom. And now that we are successfully connected to Ethereum and we have the provider canister set up and running, we can move on to the next step, which is adding a login button for the sign in with Ethereum part of things. So let's create a new component. We call it a login button. We add the use account hook from the WAGMI library to make sure that we only want this button to be active when we are connected to Ethereum, right? And then we import the use sign in with Ethereum identity hook, which provides us with the login status, the actual generated identity, as well as a login function. So let's fast forward here and add all the rest of the component. And as you can see, what this component does, it's a button with some text. We adapt the text depending on the login status, and we make sure to disable this button if during login, to preventing us to initiate duplicate login requests, and also if we're not connected to Ethereum. So let's add this button to our main application. And then finally, we also need to add one last provider that wraps our application. And that is the sign in with Ethereum provider. And what it does, it makes the generated identity available to all components within the application. So we'll connect that and configure it to use the canister that we deployed. Let's see. With the sign in with Ethereum provider in place, let's head back to the web page and see how things work out. So now we have the sign in. We have the sign in button here, and pressing it should trigger the sign in flow. So what it does is that what takes place on the hood now is like I mentioned earlier, that this React hook, it makes the request to the provider canister. It gets this sign-in message in return, and now we display it to the user. And as you can see, it is displayed in a quite nice and very readable format compared to other Ethereum signing requests. So it tells us which website we are logging into and some other details. So let's confirm that. And yeah, the button disappears, which is a signal that things worked out. But let's add one final component to all of this. I'd like to add just a simple identity component that will display the identity once we have logged in. So we will be using the sign in with Ethereum identity hook again, but this time we will only ask for the actual identity. And if we don't have an identity, we will just return nothing. Other than that, if we have an identity, we'll display it as a string. And let's see, let's add that component to our main application. And boom, there it is. What you see on the screen there is the generated ICP identity. And once we have that, we can start making authenticated calls to our backend canister. So that's it. I won't be taking this example any further at this point. I have demonstrated how you can drop the sign-in with Ethereum canister into your project and use that to authenticate the user with an Ethereum signature. to create a chain fusion application where the user can control an ICP application using their Ethereum identity. Thanks for watching. The links to all libraries and etc. that I have mentioned in this video is in the show notes. And I hope you can use this repository and example as a starting point for your own chain fusion projects on the ICP.